Hello everyone, I'm Emre ÖZTÜRK and this is our project, a biologically inspired insect-like robot with soft robotic antenna. My group mates are Engincan SAYAR and Ozan DEMİR. We are supervised by Dr. Şoran Kumbay Yıldız and Dr. İsmail Uyanık. Here is the outline of our presentation. The objective of our project is to implement bug algorithms by using soft sensors. The sensor is biologically inspired by the antenna of American cockroaches. Here in the figure below, you can see the following behavior of them. The sensor is low cost, homemade and soft. Lastly, the reason why we use bug algorithms is that they are simple navigation algorithms, so we can implement them to see if soft sensors are valid for more complex scenarios.
Project description. Soft sensors has been developed which mimics the antenna of the American cockroach, Periplana americana. Soft sensors characterization for short-range perceptive distance measurement. An autonomous wheeled robot has been developed for the implementation. The autonomous robot that is equipped with soft sensors tested for bug algorithms. Simulink environment is used for localization and navigation algorithms. The construction of the antenna is made with silicon and conductive carbon grease. The base of the antenna is made with two parts. The first part is made with a silicon rubber mixture A, hardness 4D, and the other part is made with a silicon rubber mix Ecoflex, which is much softer than the first part. Before bringing together these two parts, the second part is closed up with a cap of Ecoflex and injected a conductive carbon grease. After the attachment of the two parts, the antenna are ready to use and characterized. The characterization of the antenna is done by using the antenna in the test setup. The test setup is based on a portable car that follows a changeable wall. The car gets connected to the antenna and the sinusoidal wall that behaves like the wall to be followed is put on the test setup and the sensor data gets collected. After various processing of this data, a system is identified. A controller is programmed with respect to this identification for this sensor. The setup and the test results could be seen from the graphs given in the slide. This data is processed and the system is identified based on this data. Experiment setup. For the implementation of the bug algorithms, two arbitrary obstacles have been constructed to mimic a realistic environment model. The shapes of the obstacles specifically determined to test the limits of the autonomous robot, and by doing that, it also tests the limits of the soft sensor.
The autonomous robot has been designed to have two floors. The final version of the robot can be seen. On the first floor, there are two soft sensors, one as a bumper and the other on the side. There are also an Arduino Mega 2560 as the microcontroller, an XP, and power circuit terminal here. The second floor is a colorful surface for the camera to detect the robot.
The software simulations were done on Coppelia Sim, and here we can see the experiment setup built in simulation environment. Here we can see the localization software. In here, by using color thresholding and blob analysis, the camera sees the position of the target and the robot. These positions are sent to the robot by using the XP connection. Here we can see the robot code. On the left side, the localization data is taken from the XP and used to gather the information for navigation. Then we have the sensors and the state machines to control the states of the algorithms. Here is the bug zero algorithm. In bug zero, the robot bumps the obstacle, follows around it until the target is in clear line of sight, then starts moving to the target. Here, the bug one algorithm can be seen. In bug one, the robot bumps the obstacle. It starts following around the object until it finds the closest point to the target, then moves to the closest point and starts moving to the target. Here we can see bug 2. In bug 2, there's a line between the starting point and the target point. The robot bumps obstacle and follows around it until it reaches back on the line. After reaching the line, it moves to the target. Here are the time lapse of the results. In future work, a built-in localization by using IMU can be added. Also, mapping would be useful. Overall, we saw that soft sensors are valid to be chosen as short-range distance sensing, and the bug algorithm implementation was a success. Thanks for listening.